Have you ever wondered how you teach a computer to do something that, for us, is just second nature? Today, we're going to do just that. We're going to teach a computer how to count the vowels in a word. It sounds almost too simple, but it's the perfect way to get a peek inside the mind of a machine. So, here's the big question. How do you teach a computer to read? I'm not talking about understanding poetry, just seeing the letters on a page. Well, it all comes down to giving it a perfect step-by-step recipe. And our little vowel counting challenge? It's the perfect set of ingredients. You see, computers are brilliant, but they are also completely clueless. They're lightning fast, but they can't just glance at a word like celebration and see the 5 vowels. We have to spell out every single step. It's kind of like leaving a trail of breadcrumbs for it to follow, from the very beginning to the very end. Before we even think about the computer side of things, let's start with what we already know. How would you count the vowels in a word? Right now, just using your brain. Let's take a second and actually map out that process. You'd probably do something like this, right? You'd start a little mental tally at 0. Then you'd go letter by letter, and for each one, you'd ask yourself, is this an A, E, I, O, or U? If it is, you add 1 to your count. If it's not, you just move on. Simple, right? Well, that's our blueprint. Okay, so now let's translate that human logic into something a computer can understand. To do that, we're going to need a few key tools from the programmer's toolkit, and I'm not kidding, these are the absolute fundamental building blocks for creating almost anything. First up, we need something called a variable. The easiest way to think about this is like a little box with a label on it, a container where we can store information. We'll label our box vowel count, and to start, we'll put a 0 inside. This little box is basically our program's memory. But wait, how do we get the computer to check every single letter? We don't want to write the same instruction over and over again. That's where a loop comes in. A loop is like a tireless little robot that just repeats our instructions for each and every letter in the word, one by one, without ever getting bored. And finally, the third tool we need is a conditional. This is the brains of the whole operation. It's a simple if-then question that lets the computer make a choice. We'll tell it, if the letter you're looking at is a vowel, then add 1 to our counter. That's it. All right, theory time is over. We have our tools, a variable to store the count, a loop to go through the letters, and a conditional to make decisions. Now, let's put them to work and see exactly how they handle our example word, pineapple. So here's our test subject, pineapple. The computer gets this as its input, and now it's ready to fire up that loop and start processing one letter at a time from left to right. And here's our starting line. You can see our variable, vowel count, has been set to 0. We haven't checked any letters yet. We are ready to roll. First up, the letter P. The conditional asks its question, is this a vowel? The answer is no, so our vowel count stays right where it is, at 0. On to the next one. Okay, next letter in line, I. Is that a vowel? Yes, it is. Our conditional rule kicks in, and our vowel count variable gets updated from 0 to 1. And now we're on to N. Is it a vowel? Nope, so the count stays put, still 1. The loop just keeps chugging along. Next is E. And hey, that's a vowel, so we tick that counter up to 2. And what do we have here? The letter A. That's another one. Our running total is now up to 3. Next up is another P. The computer doesn't care that it's seen a P before. It just follows the rules. Is it a vowel? Still no. The count holds steady at 3. And, you guessed it, the next P. Same question, same answer. Not a vowel. The vowel count doesn't budge. Then we hit the L. Is it a vowel? Nope. We're still at 3. We are getting very close to the end now. And for the grand finale, the very last letter, E. Is it a vowel? Yes, it is. The count ticks up one last time to 4. And that's it. The loop has gone through every single letter and its job is done. The final value sitting inside our vowel count variable is 4. Our program worked perfectly. So you might be thinking, that was a whole lot of work just to count to 4. And, well, you're not wrong. But here's the thing. This was never really about the vowels. It was about learning the secret language of computers. You see, with this one tiny task, we've just used 3 of the most powerful ideas in all of programming. We used variables for memory, loops for repetition, and conditionals for making decisions. Honestly, that's the whole game right there. Those are the building blocks for just about everything a computer does.
And that really gets to the heart of what programming is all about. It isn't some kind of magic. It's just about taking a big problem and breaking it down into tiny, logical steps that even a machine can follow. So, now that you understand the logic for finding vowels, think about it. What else could you teach a computer to find? The possibilities are truly endless.